Hello and welcome to another session in mathematics. In this session we'll be looking at logarithms. But before that, let's take a look at the previous lesson. Welcome back. In our lesson today, we'll look at logarithm of numbers to base 10 and then multiplication and division of numbers using logarithm table. But before that, let us look at the definition of the term logarithm. We say in general, the logarithm of a number is the power to which the base must be raised in order to get the number. That is to say, if y is equal to n raised to power x, then x is equal to log y base n. I want you to note the way I am stating this. X is equal to log y base what? N. N here is the base. Okay? Now similarly, if we have 10 means 10 raised to power 1. And if we have 100 is what? 100 is 10 raised to power 2. And 1000 is equal to 10 raised to power 3. Is that correct? Now, if we apply this in the logarithm form, it means that log 1000, that is for this, log 1000 base 10 is equal to what? 3. That is, the number that 10 must be raised to get what? This is equal to what? 3. 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1000. So 10 must be raised to power 3 for us to be able to obtain what? 1000. That's just the definition of what? Logarithm. It said it's the power to which the base must be what? Raised in order to give that what? Number. We're looking at 1000. So what number must 10, which is the base, be raised to get 1000? It's just equal to what? 3. So for 100, we have log 100 base 10 to be equal to what? 2. 10 must be raised to 2 for us to get what? 100. Okay? So let's quickly look at some examples. If we have 5 raised to power 3 to be equal to 125, all we are saying here is that log 125 base 5 is equal to 3. So 5 raised to power 3 will give us what? 125. Is that correct? Yeah. So we are telling us here that 5 must be raised to power 3 for us to obtain what? 125. Okay? Assuming we have 2 raised to power minus 6 to be equal to 1 over 64, it just means log 1 over 64 base what? Base 2 is equal to what? Minus 6. Is that correct? Yeah. 2 raised to power minus 6 will give us 1 over 64. Okay? Then lastly, let's assume we have a problem 10 raised to power 4 to be equal to 10,000. This is log 10,000 base 10 equals what? 4. As simple as that. So let's now quickly look at logarithm of numbers to base 10. How we can obtain logarithm of numbers in base 10. And in this, we normally use the logarithm table. We use the log what? Table in finding the numbers in this area. Okay, so assuming we are given the number 3,900 for us to convert it to be in logarithm form. The first thing we need to do is to express this 3,900 to be in standard form. Okay, you remember that? Okay, this is equal to 3.9 times 10 raised to power what? 10 raised to power 3. Okay, now remember how we got that? That is 3,900 divided by what? 1,000. Okay, 3,900 divided by 1,000 will give us 3.9 times 10 raised to power what? 10 raised to power 3. Then at this point, what next are we to do? We now go to the table. we now go to the table, and under the table, as you can see on the screen, there's what we call the difference. There's the difference at the right extreme, and we have the numbers 0 to 9. Okay, and then we have numbers as well that we are going to search from 10 to 99. It ends at 99, 10 to 99. Now for this, we are going to look for 39 under 0. We're going to look for 39 under 0 since we have 3.9 on the screen. So we have 39 under what? Under 0. Okay, now 39 under 0 will give us 0.5911. Is that correct? Okay, since we are dealing with base 10, it means 10 raised to power 0.5911, okay, times 10 raised to power 3. And then we apply the law of indices where we have a raised to power m times a raised to power n to be equal to a raised to power m plus n. And that we have 10 raised to power 0.5911 plus 3. Okay, and then that will give us 10 raised to power 3.5911. Okay, therefore it means that we have log 3900 in base 10 to be equal to what? 3.59. okay, we have 3.599. Now in this, our 3 here is called the integer, and the numbers after the decimal point are called decimal fraction. Decimal what? Fraction. Okay, is that clear? So let's take one more example. Okay, we have two questions here on the screen. We are asked to find the logarithms to base 10. We are asked to convert these logarithms to base 10. We are asked to convert them to base 10 from what? The log table. Let us find the value of this from what? The log table. Now we search for this to be 51 under 3 difference 8. Mark what I just said now. We search for 51 under 3 difference what? 8. And then when you find your 51 under 3, you add 8 to it. Whatever you get from 51 under 3, you add it to what? To 8. And then you get your value. And when we do that, we get 1.7108. Okay, and then for this we have 65160. How do we do that? We search for 65 under 1 difference 6. 0 is not included. Okay, then you search for 65 under 1 difference what? 6. Okay, now we then have our answer to be equal to 4.8140. Let me teach you how to use the logarithm table. How do we use this logarithm table? Pay close attention to what we are doing right now, and you will understand everything bit by bit. Okay, the A part of this table is what I call what? The number. That is the number we are going to search in what? The logarithm. The B part of it is the number of digits before what? The decimal point. Like this, we have 3 here before the decimal point. The C part of it is expressing the number in standard form, and then the D part of it is called the characteristics, and the characteristics is the number before the decimal point minus what? 1. Okay, we have the mantissa from what? The log table. The mantissa from the log table, and then we have the difference. We have total mantissa, and then we have the logarithm. Okay, now let us start. Let's take an example. Remember when we solved for conversion of numbers to standard form? Okay, Now in this we have 3.5 as a number we are to search for under what? The log table 3.5. Now for this, how many numbers are there before the decimal point? That is B now. The numbers before the decimal point is just 1, which is 3. Is that correct? So we have 1. That's how we got this one. How many numbers are here before the decimal point? 1, 2, 3, 4. In this, there's no decimal point at all. So you count the numbers. They are 4 in number. That's how we got this 4. Here, how many numbers are here before the decimal point? We have what? 3. Do the same in this one. How many is here? 1, 2, 3, 4, 5. There's no decimal point. So you count the number and add 5. How many is here? 1, 2, 3, 4, 5, 6. There's no decimal point. So that's why we got what? 6 here. Okay. Let us continue. For C, the C part of the table, which is expressing the number in standard form. Now you agree with me that 3.5 is same thing as 3.5 times 10 raised to power 0. Since 10 raised to power 0 is the same thing as what? 1. Anything raised to power 0 is 1. 3.5 times 1 will still give us 3.5. Is that correct? Yeah. And 3.500 divided by 3,500 divided by 100 will give us 3.5000. So 100 is what? Equal to 10 raised to power 2. Okay, that's how we got this. Then for this, we have 875.7 divided by 100, and then we'll get 8.757, and then 8.757 times 10 raised to power 2 will still give us this. Okay, remember our SOM is to make everything here to be what? In standard form. Okay, now we have 2.8936 times 10 raised to power 4, and this will still give us this value when you multiply it through. Okay, then we have 5.21346. Here we have 5.21346. When you multiply it by 10 raised to power 5, you still get 521,346. Now for the characteristics is a determinant of where you place your decimal point after you must have searched these numbers in what? The logarithm table. Do we understand? It determines where we add them at decimal point after searching for the numbers in the logarithm table. Now I wrote something here. The characteristics is equal to number of digits before decimal point minus what? 1. This is what? Number of digits before decimal point. And here we have 1. Then we write down the 1 minus 1, and that will give us what? 0. Is that correct? And here we have 4. 4 minus 1 will give us 3. That's how we got this. We have 3 here. 3 minus 1 will give us 2. We have 5. 5 minus 1 will give us 4. We have here 6. 6 minus 1 will give us what? 5. You understand that, right? Fine. Then for searching for the letters in the log table, I taught us how to do that in a short while now. So we search for 35 under what? 0. 35 under what? 0. And when you search for 35 under 0, you have 5441. 5441. Is that correct? Fine. Now, if you search for 35 under 0, you still have what? 5441. Okay? Then for this, if you search for 87 under 5, you have what? 9420. 87 under 5. Remember, we've not touched the difference, which is 7. We've not touched this difference. Okay? Now, we have 9420. You search for 28 under 9. You have what? 4609. Then for this, you search for 52 under 1. And we have 7168. Okay? Now, we have what we call the difference. I showed you that on the extreme part of I showed you that on the right hand side of the log table here on the screen. This is where we call the difference. So whatever you get from the difference here, you add it from whatever you got from the mantissa. Okay, you add it to your mantissa, and then when you add it to your mantissa, you now get what? The total mantissa. Do you understand? Okay, now at this point, for 35, there is no difference. That's how we have none. For this is 35 under 0 difference 0, and in difference there is no 0. That's why we also have none. And for this, we have 87 under 5 difference 7, and the difference of 7 is what? 0.0 is equal to 0003. Okay, is equal to what? 0003. But there it is written as what? 3. So you write down what? 3. Okay, now for this we have 28 under 9. Under 9, we are supposed to search for difference 3, but the number after 3 is up to 5, so you round it up to become what? 4. So 28 under 9 difference what? 4. That's how we got this difference 4, and it gave us what? 6. Okay, now for this you have 52 under 1. We are supposed to search for what? Difference 3. You check the next number after 3. How many is it? 4. So it's less than 5. You search for 52 under 1 difference what? 3. And that's how we got this. Now when you must have gotten the differences, then you add them to the mantissa. That's why we have total mantissa. This plus this is 0 now, will give us this. This plus 0 2 will give us this. And then this 9420 plus 3 will give us what? 9423. And 4609 plus 6 will give us 4615. And then for this, we'll have 7168 plus 2 to give us 7170. Now, the logarithm, finally, the logarithm, which is the last part of what we are doing, the logarithm. I told us earlier that the number we obtain here will determine how we place what? Our decimal point. Now here we have here to 1 minus 1, which gave us 0. That's how we got this 0. Point, whatever we got in the total mantissa. Do we understand? Then for this we have 4 minus 1, which gave us 3. Write down your 3 and then add your point and add what? The total mantissa. That's how we got this. For this you have what? 2. 3 minus 1, 2. So write down your 2, then bring down your 9423. That's how we got this. For this we have 4. 5 minus 1, which gave us 4. So you write down your 4 and then add 0.4615. That's how we got this, and so on and so forth. Okay, let us learn about the anti-logarithm. Anti-logarithm. Anti-log is the opposite of what? Logarithm, from the word anti. Anti-logarithm table. It's just the opposite of logarithm. Opposite of logarithm table. Okay, what does the anti-logarithm entail or connote? In anti-logarithm, if you are given a number 0.5682, all you need to do is to search for 56 under 8 difference 2. Okay, let me just upload the anti-logarithm table on the screen so that you will understand what I'm saying. Here it is. You have the difference 2, and you have the path to where you search for numbers and mark the numbers. They start with what? Point something 2. Now this point we search for 56 under 8 difference what? Difference 2. 56 under 8 difference 2. And remember how I told you to do that? You search for 56, and whatever is the value, you add it to the difference you get. And when you do that, you have what? 3700. Is that correct? You have 3700. Now the question is, how do you now place your decimal point? Remember, when we were dealing with logarithm, we subtract 1, right? But in anti-logarithm, you add 1. Logarithm, you subtract 1. Anti-log, you add 1. That is why it is called what? Anti. So for 0, you add 1 to 0. What will it give you? To give you what? 1. So it means you add your decimal point immediately after the first digit of this. Therefore, we then have 3.700 as our answer. Okay, assuming then we are giving another number. Let's say we are giving 2.7547. Okay, search it also. 27 under 5 difference 5. Round it up and then add it here. It becomes 5. So you search for 27 under 5 difference what? 5. And what will you get? You get your answer to be what? 5684. Is that correct? 5684. Now remember what I told you here. you add 1. Is that correct? So when you add 1, how many is here? You have what? 3. So you add your decimal points after the third digit. So we have 568.4. Okay, as simple as that. So to refresh your memory on what we've been doing so far, I want you to take the test on the screen. Welcome back. We'll stop here for today, and in our next class we'll go over to multiplication and division of numbers using logarithm tables. Do well to use the lesson note on the platform for better information on the topic we've discussed, and feel free to drop your question on the comment section if there's any problem you encounter while solving what we've just done so far. Thank you very much for being part of today's class. Till we meet again, stay safe and bye.